So in the first experiment, we have to measure various parameters of opamp using IC-LM741. So out of which the first parameter we have to measure is the input offset voltage. So ideally for zero input, opamp should produce zero output, but practically due to some internal imbalances, it produces some output voltage which is called as output offset voltage. So in order to nullify this output offset voltage, we need to apply some voltage at the input. So this voltage is called as input offset voltage. The voltage applied at the input in order to nullify the output offset voltage is called as input offset voltage. So here we are using an inverting configuration op-amp. This is the feedback resistor RF and this is R1. So basically for calculating the input offset voltage is much of a theoretical part than practical part. So you have to derive a formula from which we can calculate input offset voltage. Input offset voltage from output offset voltage. Now output offset voltage is very easy to measure because we know that pin 6 we can connect a DMM, ground these two pins, that is input will be 0, and measure the output voltage. So that will be the output offset voltage. But to measure input offset voltage, we need to do some mathematical analysis in which you have to use a formula, this formula, which will give us the input offset voltage from output offset voltage. So we'll see how this formula came. So basically this is RF and current flowing through it will be IF, and this IF will flow from here through R1. As op-amp draws zero current, so it won't go here, that is IB2 will be 0. So current passing through R1 will be I, similar to IF. So we can say the voltage at this X point is voltage across this resistor. So it can be given IR, therefore it will be R1 I1, and I1 is equal to IF, therefore we can write as Vx is equal to IF R1. Okay, now to measure IF, we know VO minus Vx divided by RF, so that is V by R. Now Vx is nothing but input offset voltage, so VO minus VIOS divided by RF. So by substituting this, IF is equal to VIOS divided by R1 in equation 1, we will get this, and by substituting, cross multiplying and again dividing by R1, we get this equation which states that VIOS, that is input offset voltage, multiplied by the closed loop gain gives us the output voltage. So this is input voltage into gain is equal to output voltage. Now we know the output voltage, as we can measure it at the output pin. We need to calculate or measure VIOS, that is input offset voltage. So what we'll do, we'll divide, shift this entire term over here. So we'll get VIOS is equal to R1 divided by R1 plus RF into VOO, that is output offset voltage. Now we'll see how to measure this VOO practically. So this is a breadboard. We will be using breadboard to make connections and build the circuit, but due to lack of components, I'm going to draw this circuit and explain. So here I have drawn a IC741 op-amp. So we will first recognize its first pin by placing its notch on our left side, and the first pin facing toward us will be the pin number 1. Our second mark for identification will be, there will be a small dot over here which would indicate that the pin next to it will be the pin number 1. So accordingly we will name all the pins, pin number 1, 2, 3, 4, 5, 6, 7, 8. So we'll place this IC like this over here on the breadboard, and we'll make the further connections. So we have to make connections similar to this on the breadboard. Here we'll see now how it is done. So this is the IC. So name the pins from the notch, that is pin number 1, 2, 3, 4, 5, 6, 7, 8. So according to the pin configuration, the pin number 2 is inverting pin, pin number 3 is non-inverting pin, pin number 4 will be minus VE, pin number 6 will be output pin that will give us output voltage. Pin number 7 will be plus VCC. This will be NC and all offset. This that can be ignored right now. So first we have to apply the biasing voltage, that is plus VCC and minus VCC. So in order to apply, we have to give it minus 15 volts and plus 15 volts DC. 15 volt DC. So to generate this bias condition, we will use a dual regulated power supply. Here we need to use two power supplies. So this is power supply 1, power supply 2, and it would be having two polarities, plus minus, that is positive negative and positive negative. So we'll do one thing, that will, this is power supply 1, power supply 2, we short the minus negative terminal of power supply 1 and positive terminal of power supply 2 altogether like this, and take a common wire out of it which will act as a ground. Negative of power supply 1 and positive of power supply 2, and take a common wire out of it which will act as ground. The positive of power supply 1 will act as plus VCC, negative of second will act as minus VE. We have to adjust the knobs over here and set the voltage to 15 volts. So this would create a perfect bias condition, it is plus VCC and minus VCC with ground. So we will insert the minus VE and plus VE plus VCC, and so here we'll be making the connections of breadboard. So we have two channels for power supply, that is grounding and biasing. So what we'll do is, we can do one thing, we can keep, now this is short and this is short, and there is isolation between these two. So we can take a wire or this plus VCC and insert it over here, take a wire of minus VE and insert it here. So here we'll get plus VCC, here we'll get minus VCC, and on the other side altogether we'll connect the ground wire, so this will become ground. Now we have placed our IC over here like this, so it will be placed over here. So we have to make connections like this, similar to this. Now here we can see that between the pin, output pin and inverting pin, there is one feedback resistor RF connected. So this is output pin is pin number 6, inverting pin is pin number 2 according to the pin configuration. So we will connect a resistor RF in between those two pins. So here we can see pin number 6 and pin number 2, there is one resistor RF connected. Now similarly this R1 is connected to pin number 2 and is grounded on the other side. So here pin number 2, R1, ground. So we have to make similar connections over here. Can use this and this space for that, because over here the IC will be placed, and our connections will be done. But one important thing to measure input offset voltage is the input should be 0. So we'll now pin number 2 is already grounded, that is the inverting input. We need to ground pin number 3 in order to create 0 input differential input voltage. So we'll ground it, the pin number 3 will be grounded, okay, and then we'll measure the output voltage at pin number 6 through by using a DMM. So DMM is this, and we'll use a positive or red cable to measure the output voltage, and the black cable or common wire will be grounded. It can be grounded by taking out wire from the ground itself, the jumper cables. Okay, so the output voltage can be measured like this. So by turning this on the voltage side, we'll get some reading over here which will be output offset voltage, VOO. So we'll get the reading over here, that will get when the two inputs are grounded and we are biased it correctly, it will be the output offset voltage. Now we have derived our formula over here to calculate input offset voltage. We need to multiply this with output offset voltage. Now this will be knowing priorly, because we will be connecting these resistors, that is R1 and RF, we have connected over here. This is RF, this is R1. These values will be known to us,